Hello everyone. So now we'll study the multi-stage compression. We'll study that how the multi-staging affect the compression process. So here in this figure, there are two compressors involved, compressor 1 and compressor 2, and there is a reservoir in which the compressed air is filling. And in between there are some intercoolers are involved. So now we'll try to understand that what is the function of these intercoolers with respect to the multi-stage compression. So from this figure, from this PV diagram, we are seeing that first the compression process takes place from 1 to 1 dash. That is 1 to 1 dash. Compression follows the polytropic process of index n. Then after 1 dash to 2, there is an intercooler involved. And the function of this intercooler is to decrease the temperature of the compressed air. It decreases the temperature by removing the heat. So in the intercooler at a constant pressure, it's removing the heat. It is removing the heat. So it comes from 1 dash to 2, and then from 2 to 2 dash there is a second compressor involved, and it follows a polytropic process and compresses the gas. And after 2 dash to 2 dash to 3, there is again a what is that intercooler aftercooler is involved, by which its temperature is decreasing, and at the end it is coming to point 3, which is the reservoir. So here we are seeing that by using the intercooler, if we'll follow the compression process from 1 to 3 directly without using the intercoolers, then we have got to this point. And we can see that by going to that path, we have to work this more amount of work. We have to supply this much of amount of work extra. So by using the intercoolers, actually uh, we are saving the work. So effectively we can see that we are coming from 1 to 3 from this path by saving this much amount of work. Okay, and this path is actually the isotherm. This is called isothermic path. If we would have taken the more amount of compressor, then it is coming like this multi-staging. I mean, infinite number of multi-staging. Then it follows the isothermal path. So it means that we practically it is not possible the compression process isothermally. So we can, by using the multi-staging, indirectly we can follow the isothermal path by to save the amount of work supplied. Okay, so let us try to find out quantitatively that how we can understand that. That we want to compress 1 bar of pressure to 36 bar by using only single stage, and we are taking that polytropic into 7.3 and clearing volume 5%. So we are getting that volumetric efficiency is 26.27% only. So we can say that only this much amount of fluid we are able to compress. But if we are following this multi-stage at two stage, so in two stage, first we are doing compression from 1 to 6 and then 6 to 26 to 36 by taking all the coefficient same, then we are getting that the volumetric efficiency becomes 85%, almost 3 times. I mean 85% of amount of fluid we are able to compress. So it means that multi-staging is a very important and very beneficial for compression process. So for let's say P1 is 1 bar. So for uh, if we want to compress 1 bar to 5.5 bar, then only single stage compression is sufficient. From 5.5 to 35 bar, double staging is sufficient, and then from 35 to 180 bar, triple staging would be required. Okay, so here we can conclude that as the pressure ratio increases, volumetric efficiency decreases, and therefore multi-staging becomes compulsory beyond certain pressure ratio. It also saves the construction cost of material and leakage across the piston. After intercooling is used in between the stages, work input required by the compression can also be minimized by using the multi-staging. Okay, now we'll try to understand that intermediate pressure for minimum work input required. How can we find out that? Like here, we are seeing that intermediate pressure is this. This is the intermediate pressure, but that also can be here. So how can we define that intermediate pressure should be where? What? How much amount of intermediate pressure? So for that we can use the calculus. So let's say we are using only two stages for compression 1 and 2. So for that we can use the formula for compression 1, P1 to P2 and then P2 to P3. Let n minus 1 upon n taken as x. Okay, so we can write it in terms of x we have taken. Now the compression work, we want to minimize the work with respect to P2 because we want to find out P2. Okay, so with respect to P2 we have differentiated it and we have put it equal to 0. So we are getting P2 is equal to this much amount of intermediate pressure. And for perfect intercooling, T1 is equal to T2. From this graph we can see that for perfect intercooling, T1 is equal to T2 because it is isothermal process. So temperature will be constant. Temperature will be constant in this line. Okay. So for perfect intercooling, T1 will be equal to T2. So P2 will be square root of P1, P3. That's it. Or we can say that P2 upon P1 is equal to P3 upon P2. From this figure we can say that this is 1, this is 2, this is 3. So we will say that P2 upon P1 is equal to P3 upon P2. Means this ratio will be equal to this ratio. Then we will get the same temperature on that line, on the isothermal line. Okay. So, or we can, in the other words, we can say that the intermediate pressure will be the GP of the consecutive pressures. If there are n stages in multi-stage compression with perfect intercooling, pressure ratio across each stage compression will be equal to one simple P2 upon P1 is equal to P3 upon P2 is equal to P4 upon P3 is equal to Pn plus 1 upon Pn, means next to the first. We can take a k and we can use wherever we want. So if we will put that P2 is equal to Kp1, then P3 is equal to K square P1, P4 is equal to K cube P1. So we can make this formula Pn plus 1 is equal to K to the power n P1 and K is equal to P2 upon P1. Okay. Pn plus 1 upon P1 is equal to Pr. Overall pressure ratio if we had taken K is equal to Pr into K is equal to Pr. Take overall pressure ratio as pressure ratio across a stage. Okay. K is equal to PRS. PRS is equal to pressure ratio across the stage. Then PR naught, that is PR naught, that is overall pressure ratio is equal to PR across a single stage to the power n. Overall pressure ratio is equal to pressure ratio across a single stage to the power capital N, and is the number of stages. Okay. And the second thing is that if we'll apply this formula in the compression work in this WC1, WC2, applying T1 is equal to T2, then we are seeing that the compression will be same. Compression work will be same. So the important point to note here that for perfect intercooling with minimum work input, pressure ratio across each stage compressor will be equal Pressure ratio across each stage compressor will be equal, and each stage compressor require equal amount of work. Each stage compressor requires equal amount of work. That's it. Now here are some uh, question, and then now the next topic is free air delivery. So what is free air delivery? We'll cover this topic in the next session. Till this, thank you.